This is a video of Lesson 9 and how to make tables of equivalent ratios. This week, we've been working a lot about finding equivalent ratios. So we have a couple of different strategies we can do. We have the what I like to call the double V diagram. If I have a ratio of 2 to 3, as long as I multiply both numbers in the ratio by the same number, such as 4, 2 times 4 is 8, 3 times 4 is 12. If these are the same, I have 2 groups of 4 and 3 groups of 4. In the tape diagram wise, that would look like this. That tells us, whoops, my stuff is sideways. Sorry about that. Here, how's that? Just got started and didn't check my video. So, we have a tape diagram to demonstrate it. We have 2 groups of 4 and 3 groups of 4. As long as we keep these groups, these units the same, we can change inside here and get 8, 8, 8, 8, 8. And then we could have an equivalent ratio that would be 16 to 24. So now, and then yesterday we learned how to find the value of ratios, or the simplified version, which was basically scaling down the versions or the ratios. So if we had a ratio such as 12 to 36, we can write that as 12/36 and then simplify it, divide by 12, divide by 12. We get 1/3. So that would be a ratio of 1 to 3. So when we make ratios bigger that are the same or equivalent, it's called scaling them up. And when we make things smaller, it's called scaling it down or simplifying. Now that we know how to make all of these ratios, we need to know how to organize them. And mathematicians like to organize their data in tables. So now, if you don't have this sheet yet from your teacher, you need to go get the sheet to glue into your math notebooks. And we're going to take some notes about how to use these tables. Woo! Sorry, technical difficulties today. How to use these tables to organize all of our sets of equivalent ratios that we can come up with now. So go get the paper and glue it into your math notebook, and then push pause until you are ready to begin taking the notes. Okay, you should be back with me now. So we always start by reading the entire problem so we know what context we're dealing in. To make paper mache, the art teacher mixes water and flour. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. Are your math antennas tingling? Because that sounds like some ratio language to me. Sometimes she needs to just make the recipe for herself. Sometimes she needs to make the recipe for a group of students in art club. Sometimes she needs enough for an entire class. And one time, all of 4th grade asked her to make paper mache maps. So we need to find equivalent ratios for the ratio relationship of 2 cups of water to 3 cups of flour. Right here, remember, this is a ratio description, and it has that ratio language in it. Cups of water, 2 cups of flour. For different amounts of paper mache that Mrs. Lerno might need to make. Represent the equivalent ratios in the table below. So this is an example of a vertical table going up and down. Vertical means up and down, like a basketball player or a volleyball player likes to have a large vertical jump. They like to be able to jump high over the net or to the basket. Up here we have our labels so we know what we're looking at. And we have cups of water here and cups of flour here. In this last column, we're going to find the value of the ratios just to continue practicing from our previous lessons and to make sure that we have indeed found equivalent ratios. So the smallest amount we would need is 2 cups of water to 3 cups of flour. And remember, in these videos, whenever I write something on my paper, you should write it in yours as well. So we're starting off with a ratio of 2 to 3. Now is when we use our strategies to make these bigger and make equivalent ones. So if I have 2 to 3, I could do 2 times 2 and get 4, and then 3 times 2 and get 6. That value over here, this one would be 2/3, because the value of a ratio is a fraction in lowest terms. This one would be 4/6, but then when we simplify it, it would go down to 2/3. After 4/6, we could do 3 groups of 2. And again, I'm visualizing this simplified one as my tape diagram. So if I have 2 boxes to 3 boxes, and then if I have 2 in each, that's where I get my 4. If I had 3 in each, I would have 6 here. 3 in each of these units here would give me 9. So that would be a ratio of 6 to 9. 6/9, but simplified. Divide by 3, divide by 3 would give me 2/3. Next, I would have, if I had 4 in each box, or 4 groups of 2, so times 4 times 4, I get 8/12. 8/12 simplifies, divide by 4 to 2/3. When you're making the table, you can use these strategies, or once you get it going, you might pick up on a pattern and be able to utilize the pattern to get further equivalent ratios. So I notice this column is going 2, 4, 6, 8, so the next one would probably be 10. Over here, it's going 3, 6, 9, 12, so I see a pattern of +3, +3, +3, +3, so this one would be 15. Then just to make sure that I did it correct, 10/15, if I simplify that, divide by 5, I get 2/3. So I know that all of these are equivalent ratios because all of these are equal. So when the values of the ratios are the same, the ratios are considered equivalent. Next, we're going to look at Javier, and we're going to look at a horizontal table example. Sometimes we will see data, or some students prefer to organize their data left to right or horizontally versus vertically. So here is another option for you, or one that you might see and you need to know how to read. Javier has a new job designing websites. He is paid at a rate of $700 for every 3 pages of web content that he builds. Right there, my math antennas are tingling. For every, that sounds like a ratio. Rate, I know, is a specific type of ratio. So he create a ratio table to show the total amount of money Javier has earned in ratio to the number of pages he has built. So again, be careful with your total pages built, your labels, total money earned, because this is in an opposite order. So we have to make sure we're plugging in the numbers where they should go. So in this case, it's $700 for every 3 pages. So if he builds 3 pages, he earns $700. Well, if he builds 6 pages, how much would he get? Well, that's double 3 pages, so I'm going to double this. That would be $1,400, or times 2 times 2. The value of this ratio is 3/700. The value of this one, divide by 2, 3/700. The next one, if he built 9 pages, 3 times 3 is 9. 7 times 3 would be 2,100 pages, or money, sorry, $2,100. Now I see the pattern, 3, 6, 9, so it's just going to go 12, 15, 18, 21, 24. And I notice that this is going up by my basic facts of 7, 14, 21, so this would be 28. This would be, that's times 4 times 5 is 35, 42, 49, and 56. Again, I could do these values down here, and I got to simplify it. Divide by 3, that would be 3/700. So this is how we would organize it in a horizontal method. The ratio we could pull out of here would be 3/700, so it would still look like 3/700. This one would be 12/2800. The values would be the fraction version. We have an extra little piece right here that says Javier is saving up to purchase a used car that costs $4,200. Oh, I noticed I have too many zeros up here now that I see those. Did you guys notice that when I was making that mistake? I usually find them. So he wants a used car that costs $4,200. How many web pages will Javier need to build before he can pay for the car? So that's another reason these tables are nice. If he knows this is what his goal is, 4,200, he can come up here and find 4,200, and then that'll tell you he needs to build 18 web pages. So how many does he need to build? 18 total pages. These tables should look familiar to you from other data that you've collected and how to organize them. We're just using it with ratios now and applying it to that context.